Hello everyone. Today we are going to see about mesh and nodal analysis. The topics that what we are going to cover in today's session is Kirchhoff's voltage law, mesh analysis, the problem in a mesh analysis, then Kirchhoff's current law, a generalized nodal analysis and a problem in the nodal analysis. Now, first we are going to see what is a Kirchhoff's voltage law. Kirchhoff's voltage law states that the voltage drop across any closed circuit is equal to 0. That is, the voltage applied is equal to voltage dissipated. It follows the energy balance equation, that is, no energy can be created and no energy can be destroyed. That is, the voltage applied is equal to the voltage drop in the circuit. Here, let us take any circuit. Here we have taken a circuit that has two loops. A loop is nothing but see here, the circuit is having two loops. The loop is nothing but it is a closed path in the circuit. Well, similarly, here we have the loop 2 here, and we must know what is a mesh. The loop is a closed circuit and mesh is a loop that doesn't contain any loop within it. A mesh is a loop that doesn't contain any loop within it. It is applicable to all planar circuits. So in Kirchhoff's voltage law, the applied voltage is equal to, here the applied voltage is the voltage given by the battery, and the voltage drop is the voltage drop across all the resistors. So when you add all the voltage drop, it must be equal to the applied voltage. This is what the Kirchhoff's voltage law. This is particularly useful in mesh analysis. So we will see the generalized condition for mesh analysis in the next slide. Now we'll go for what is a mesh analysis. See, for mesh analysis, any circuit can be treated as a mesh. So let us take this circuit diagram. This circuit diagram is having a mesh. What is a mesh? A mesh is a loop that doesn't have any loop within it. So this is one loop, this is one loop, right? So here what is a loop? Actually, a loop is a closed circuit. So here this one is first loop and this one is the second loop. When you see the the circuit diagram has two loops in it, loop 1 and loop 2. It has a battery. It has a battery which is uh, it has a battery here, which is battery source, which is a voltage, and there are resistors where we can have the voltage drop over it. Okay, and this is so now we will try to frame the equation and we will try to find the solution. So what for we'll go for mesh analysis is the usually we will go for mesh analysis when the input source is a voltage source. That is, when the input is a battery. Here the input source is a battery, therefore we are going for mesh analysis. In mesh analysis, usually the output will be a current. Okay, so here the voltage is given. So what will be my output? My output is a current. Okay, so in mesh analysis, we will assume the given circuit diagram as mesh. So here in the given circuit diagram, there are two loops, loop 1 and loop 2. Here the current direction is given. The current direction is a clockwise direction. If the current direction is given, you have to take that current direction. Otherwise, you have to assume the current direction. Here, it is clockwise, and when you are assuming, both the loop must be in the same direction. So here, this is also, the first loop is also a clockwise direction. The second loop is also a clockwise direction. Okay, so we are going to take it and let us assume or let us consider this is my input source, which is a voltage source, that is the input voltage drop, and these are the resistors R1, R2, R3 and R4 where you are getting voltage drop, and here I1 is the current flowing in loop 1 and I2 is the current flowing in loop 2. Okay, so here it is in the first loop you are having a current I1 and in the second loop you are having the current I2. Now we will try to frame the equation. Let us write the equation and then we will see it here. Let us take the first loop here. In the first loop, the applied voltage is V. Okay, and the voltage drop is across R1 and R4. In the first loop, it is the applied voltage is V and the voltage drop is across R1 and R4. And here the current flowing through loop 1 is, as it is stated earlier, it is given in the circuit diagram as I1, I2. So how you have to write the equation is, we know by Kirchhoff's current voltage law, in mesh analysis we have to follow KVL. So by KVL we can write it as it is the applied voltage is equal to voltage drop. So what is the voltage drop across R1? It is I1 R1, because we know by Ohm's law voltage is equal to I into R. So across resistor R1 the voltage drop is I1 R1. Okay, what is then the voltage drop across R4? It is again I current into the resistor. What is the current flowing through R4? See here in loop 1 the current is I1. Okay, in loop 1 the current is I1. Okay, now let us take the loop 2. When you take loop 2 the current is, let us take it as I2. Okay, so when you see the current direction, the red color is in clockwise direction. Okay, similarly I2 is also clockwise direction, but you just see through R4. Okay, through R4 the current I1 is flowing from uh, top to bottom, and through R4 the I2 current is flowing from we will go with a different color. It is from bottom to top. So through R4 it is the I1 is flowing from top to bottom. Through R4 the current I1 is flowing from top to bottom, and through the same R4 the current I2 is flowing from bottom to top. So here I1 and I2 they are in the opposite direction. So across R4 our current direction is, it is I1 minus I2. This is my tow current into, what is my potential drop? It is current into resistor. So I1 minus I2 into R4. Okay, so it is I1 R1. Through R1 it is I1 R1. Through R4 it is I1 minus I2 into R4. Okay, so when you see now it is these are the voltage drop. What is the voltage applied here? When you take the clockwise direction, the current is flowing inside the battery. When you take the clockwise direction, the current is flowing inside the battery from minus to positive. Okay, from minus to plus it flows. So we will take it as minus V1 equal to 0. Okay, why you are taking it as minus um, it is minus v1? Why you are taking it as minus? When you see the current direction, the current is flowing through r1, r4, and then through the battery it flows like minus to plus, so you are taking it as minus v1. Okay, now you group it, group I1 to one side and I2 to another side, and V1. Okay, we will see through an equation. According to KVL, it is V is equal to I1 R1 plus I1 minus I2 into R4, which is our equation. And here this V is taken outside. Okay, rearranging this equation, we are getting I1 into R1 plus R4 minus I2 R4 equal to V. This is our for the first loop. For the second loop, we will see. Okay, for the second loop we will see. In the second loop, this is my second loop, right? So the current direction here is a clockwise direction. So there is no battery, so we are going to write it directly. What is the current flowing through R2? It is I2 R2. Then what is the current flowing through R3? It is I3 R3. Okay, then it is the same current is flowing through R4. Okay, if where the R4 is in between loop 1 and loop 2. Okay, so when you are seeing loop 1, the current is flowing from top to bottom. When you are seeing through loop 2, the current is flowing from bottom to top, which is the reverse of the direction. So I1 and I2 flows in the opposite direction. So we can write it as, it can be written it as plus I1 minus, see in the previous case it is written as I1 minus I2. Here we are going to write it as I2 minus I1. Why you are writing it as I2 minus I1? Because you are considering the second loop. So you are going to write it as I2 minus I1 into R4. Okay, so thus we are there is no voltage drop here, so I am not there is no battery here, so I am not going to consider this. So the same equation according to KVL in the loop 2, we can write it as I2 R2, which is across R2, and I2 into R3, which is here. Okay, and then I2 minus I1 into R4. Rearranging this, you will get it as I1, arrange I1 first, I2 second is equal to 0. Now you represent all these things in matrix form. When you are representing this in matrix form, it is yeah, you represent equation number 3 and 6 in matrix form, and you will be getting like this. That is, so what is the coefficient of R1? It is I1. So, sorry, you please go through equation number 2. What is the coefficient of I1? It is R1 plus R4. That's why it is written over here R1 plus R4. And what is the coefficient of I2? It is minus R4. So, it is written here as minus R4. And then this is minus R4. Why you are writing this is minus R4? It is here, it is minus R4, here it is R2 plus R3 plus R4. So this is written over here. Okay, it can be written in matrix form. You frame the equation, convert the equation number 2, convert the equation number 3 and 6 into a matrix form. From that we can find out I1 and I2, which is equal to del 1 by del 2. Okay, so the question now here is we are going to find out the current through 10 ohms. Okay, they will give you the circuit. This is the circuit. Okay, we are going to do this circuit in a mesh analysis. Okay, for doing mesh analysis, the question is find the current through 10 ohms. So where is 10 ohms? Here it is 10 ohms. This is 10 ohms. We are going to find out the current through 10 ohms. Okay, so here there is similar to the previous generalized formula. Here we have a circuit that has two mesh in it. Okay, so the first and the foremost step in mesh analysis or in a KVL analysis is we have to assume the current direction. Okay, so here what we are going to do, I am going to do the assume the current direction, because the current direction is not given. We will assume the current direction as we can assume it as either positive or negative. So I am going to assume that as a or it is not a positive or negative, clockwise or anti-clockwise. Okay, so I am going to assume this is a clockwise current direction. So when you assume, now you have assumed this as a clockwise current direction. Now we will write the loop equation for the first loop or for the first mesh. Let us take the first loop current as I1. Let us take the second loop current as I2. Okay, now we can write the equation. It is 10 into I1. So the first current is 10 into I1. Okay, and then now we'll see 5. When you see 5, the current I1 flows from top to bottom. Okay, whereas the current I2 flows from bottom to top. So I1 and I2 are in the opposite direction. So I can write it as plus 5. Okay. So this is 5 into I1 minus I2. Okay. Excuse. I1 minus I2. Okay, so where is the battery? The battery is a 10 volt. Here when you see the battery, the current flows inside the battery. When you take the clockwise direction, it flows inside the battery from minus to plus. So it is minus 10. Why you are writing it as minus 10? Inside the battery it flows from minus to plus. So it is minus 10 equal to 0. Now you rearrange the equation. So this becomes 15I1 minus 5I2. See here. 15I1. Okay, here also 10I1 plus 15I1 minus 5I2, which is equal to 10. Similarly, we can write the loop equation, or we have to write the mesh equation for the second mesh. Okay. So the current flowing in the second mesh is I2. Okay, so we can write the equation as 20 into I2. So it is 20 into I2. Then 5 is between I1 and I2. So we are writing it as plus 5. As it is between I2 and I1, and also here the current directions are opposite. That is, I1 is flowing from top to bottom, whereas I2 is flowing from bottom to top. Okay, so plus 5 into I2 minus I1, because you are concerning about the second equation. So you are writing it as, instead of I1 minus I2, you are writing it as I2 minus I1. Okay, and then there is a battery here. See, in the generalized equation there is no battery. The battery, that is the current flows inside the battery, is what about the current direction? Here the current direction is actually positive, clockwise direction. So here the current flows inside the battery as minus to plus. So we are writing it as minus 20 equal to 0. Okay. So in KVL, in mesh 2, it is it is 20 plus 5, 20 by 20 I2 plus 5 I2 minus I1 minus 20 equal to 0. It is similar to our previous equation. So we are getting like this. Okay. When you see this, see here, this is 20. Okay, so that's why it is here 20 I2. Here it is 5. So that's why here it is 5 into, why it is I2 minus I1? It is between the first mesh and the second mesh, and we are concentrating on the mesh 2. That's why it is I2 minus I1. If it is mesh 1, it is I1 minus I2. Okay, then the current flows inside the battery as minus to plus. So that's why it is minus 20. You rearrange the equation, it becomes 20 minus 5 I1 plus 25 I minus 5. Excuse me, there is a small mistake. Minus 5 I1 plus 25 I2 equal to 20. Okay, and now you represent all these equations in matrix form, which is 15 minus 5 minus 5, 25, and find out delta, delta 1 and delta 2. Delta is the determinant of this one. Okay, this is delta. What is delta 1? Delta 1 is, you have to replace the first column. Replace this first column, 15 and minus 5. Okay. You replace the first column with the resultant matrix. That is delta 1. What is delta 2? You replace the resultant one with the second column. Okay, that is delta 2. Okay, now find out the answers. For delta, it is 350. That is 15 into 25 is 375 and minus 25. So, if for delta, delta 1 and delta 2. What is the difference between delta 1 and delta? In the first column is replaced by the resultant column. Okay, so when you are finding out, it is delta 1 is equal to 350, delta 2 is equal to 350, and when you are calculating I1 is equal to, the formula is del 1. This is called Kramer's rule. I1 is equal to delta 1 by delta, which is 1 ampere, and I2 is also delta 2 by delta, which is 1 ampere. Okay, so the current through 10 ohms is nothing but the first equation, which is 1 ampere. Okay, this is about a mesh analysis. So in mesh analysis, we will use KVL, and if the direction is not given, you have to assume the direction is up clockwise. Either both the directions are clockwise or anti-clockwise, and you frame the equation. When you are framing the equation, the middle resistor always carries the difference between the currents, either I1, I2 or I2 minus I1. You frame the equation, and if the current flows inside the battery as minus to plus, it has to take it as minus. Okay, so here it is minus, here also it is minus. Okay, this is about mesh analysis. What we are going to do now is, we are going to see the nodal analysis, and we are going to see the same problem in nodal analysis. So nodal analysis, before getting into the nodal analysis, we must know what is Kirchhoff's current law. Similar to voltage law, it states that the Kirchhoff's current law states that the current at any point is zero. So it is Kirchhoff's current law is applicable to nodal analysis, and the sum of all currents at a node is zero. Node is a junction of two or more elements. So we'll see this circuit. This circuit has a current source. Okay, the if you give the source like this is not a battery. You have to put a circle, and inside it you put the arrow mark. The arrow mark represents the current direction, okay, current source. And we have resistors here. So the nodal, in Kirchhoff's current law, the first and the foremost thing is the nodal analysis. That is, we have to find out what are the junctions or what are the nodes. Node is a junction of two or more elements. So this is a node, okay. It is a junction of R1 and R3 and current. Okay, the next node is this. It is a junction of R1, R2 and R4. The next node is this. It is R2 and R5. Okay, the final one is there is a reference node. So Kirchhoff's current law states that the current at any point is equal to 0. That is, the summation of the incoming current is equal to outgoing current. We will explain this with the, or we will see this explanation with the given circuit. So this is my circuit. Okay, first we will concentrate on the first node. So in the first node, we will see what are the incoming currents and what are the outgoing currents. In the first node, the incoming current is I1. Okay, so you are writing it as I1. Okay, and in the first node, the outgoing currents are R1 and R3, because these are the resistors that are connected with the node 1, R1 and R3. So we can write it as, instead of voltage drop, you have to write it as currents. What is current? Current is equal to V by R. What is my V here in R3? 1 minute. In R3, what is my V here? This is, it is nothing but V by R. So here let us take the first point as the voltage as V1. So it is V1 by R1. V1 by R3. Okay, excuse. V1 by R3. So how you are arriving for this V1 by R3? First, we will see the incoming current here at the foremost step is to, you have to identify the nodes. So I have identified the node as V1. Okay, this is V1. So to V1 the current is I1. That's why I have written here as I1. To V1 there are two resistors connected, R3. This is R3. Okay, R3 is connected between V1 and ground. Okay, so I am writing here as V1 minus 0 by R3. So I am rewriting this as V1 by R3. What is the next resistor? The next resistor connected here is R1. R1 is connected between V1 and V2. So I am writing it as V1 minus V2 by R1. Okay, so now you group it. So we are getting it as V1 into 1 by R1 plus 1 by R3 minus V2 by R1. Similarly, we will go for the second mesh. Okay. Sorry, second node. The second node is V2. There is no current source, so you are writing it as, there is no current source. So you are writing it as 0. 0 is the incoming current. What is my outgoing current? All the resistors that are connected with this particular node is called the outgoing currents. So here, as it is a second node, we will take it as a V2. Okay, so it is V2 by R4. Okay, and then the next resistor is V2 is connect, the next one is R1. It is, therefore you can write it as V2 minus V1 by V2 minus V1 by R1. Okay, and the next resistor, what are the next resistor? We have finished R4, we have finished R1, and the next resistor is R2. It is between 2 and 3. Okay, so you have to write it as plus along with this. Okay, plus V2 minus V3 . Okay, V2 minus V3 by the resistor is R2. The second loop, it is V2 by R4. We have done this. V2 minus V1 by R1. V2 minus V3 by R2. Okay, so we will check the answers here. In node 2, in node 2, see here, it is V2 by R4. I'm having V2 by R4. Then V2 minus V3 by R2. So this is and V2 minus V1 by R1. Now you rearrange it and you will get it as a V1, V2, V3. Similarly, we have to do for the third node also. What is my third node here? Okay, so here we will take this circuit and implement for node 3. So for node 3, there is no the current source is I2. I2 is flowing towards the node. Right, the incoming current is equal to outgoing current. There is no outgoing current, so here I am writing it as 0, and I2, there is a current but it is flowing towards the node. Okay, so flowing towards the node in the sense this is flowing towards the node. Okay, so it is I2 is flowing towards the node. We'll take at one side. Okay, the incoming is 0, the outgoings are I2 plus, then through the third resistor, what are the, through the third node, what are the resistors that are connected? R5 and R2. So it can be written as R5. R5 is between V3 and ground. So we can write it as V3 by 1 minute. So V3 by R5. Similarly, you can calculate for R2. It is almost V3 minus V2 by R2. That we'll see here. See here, you are getting V3 R by R5. And this is V3 minus V2 by R2. And okay, sorry, a small correction here. The incoming current, the I2 is flowing towards the node, right? So that is called the incoming current. So this I2 has to be written here. It has to be written here because incoming current is equal to outgoing current. Okay, so you have to write it, rearrange this equation, and now I'm getting three equations for node 1, node 2 and node 3, and now you represent everything in matrix format. Already we have done this. Okay, so now you write the coefficients. So for the for the first equation, the coefficient are 1 by R3, 1 by R1. See here, it is 1 by, when you're grouping it, it is for grouping. After grouping, V1 coefficient is 1 by R3 plus 1 by R1. For V2, it is 1 by R1. Okay, the second equation, the coefficient for V1 is minus 1 by R1, which is written over here, and then all these things are positive for V2, 1 by R4 plus 1 by R2 plus 1 by R1. This is written over here, and for R2 it is V3 by minus V3 by R2, that is minus 1 by R2. Similarly, for coming for the ninth equation, there is nothing called V1, so it is written as 0. Okay, so this is written as 0 because there is no V1 here. Okay, then for V3 the coefficients are R2 and R5, so it is written over here. Okay, for V2 it is minus 1 by R2, it is written over here. Okay, so now we can do the matrix multiplication. We can find out delta, delta 1, delta 2, delta 3 and all. Then we can find out V1, V2, V3. Okay, so nodal analysis is Kirchhoff's current law or nodal analysis will be used in finding V1, V2 and V3. Okay, Kirchhoff's voltage law is used to find out I1, I2 and I3. We will see a problem associated with the nodal analysis, the same problem. Okay, so here instead of mesh analysis, this must be a nodal analysis. So the first and the foremost step is to find out what is the node. Node is the junction of all the elements. So this is my junction. Okay, and this is my junction. Let us take this as V, and this is one junction where in the previous problem the potential is not given, but however here the potential is given as plus 10. Here it is given as minus 20. Okay, now we will mark the incoming current and outgoing current. Incoming currents are the currents taken from the current source. Okay, but here there is no current source. The outgoing currents are, incoming currents are from the current source. What is current source here? Current source is something like this. This is called current source. We don't have the current source here, so there is no incoming current. Outgoing currents are the currents flowing through resistors. Okay, so here there is a resistor, here there is a resistor, here there is a resistor. 10 ohms, 5 ohms and 20 ohms. Let us assume the center one is V. Okay, so it is V minus, here that is first we will find out, see there is no incoming current, so we are writing it as 0. Incoming current is equal to, there is no incoming current, so you are writing it as 0. Outgoing currents, there are 3 resistors, so 3 outgoing current. First we will see at 10 ohms, so 10 ohm is between V and 10, right? So it is V minus 10 by 10. Okay, for the next one, the current, please see the yellow, the current is flowing through 5 ohms. Okay, here the voltage is V. 5 ohms is between V and 0. Okay, so we can write it as plus V. 5 ohm is between V and 0. So it is V minus 0 by, V minus 0 by 5. Okay. Similarly, we can write it for the third resistor. What is my third resistor? My third resistor is 20 ohms. It is between minus 20 and V. Other things we can rub. Okay. So here it is minus 20. Here it is V. So the 20 ohm resistor is between V and minus 20. So we can write it as V minus 20. Okay. Because current flows from positive to negative. So that's why you're writing it as V minus the potential. Okay. Divide by 20. Why you're writing like this? It is in the form of V by R. Okay, the voltage is here V and minus 20 and the resistor here is 20 ohms. Okay, now you group it. So this is what we have written in the equation. It is V minus 10 by 10. Okay, this is my equation. And V minus of minus 20 by 20. Here it is V by 5. Here it is. Which is equal to, there is no current source. So I am writing it here as 0. Here is also it is 0. Okay, now you group it. You will get it as V is equal to 0. The question here is current through 10 ohms. What is the current through 10 ohm? 10 ohm is between V and 10 volt. Okay, so you can write it as the current flowing through 10 ohm is, we know it is V by R. V minus 10. Okay, because the resistor 10 is between V and 10 volt. Okay, so V minus 10 by resistor V by R. V minus 10 by R. Okay, so it is, excuse me. Okay, the same problem we are going to see. We are seeing. So this is 0 minus 10 by 10. So it is minus 1 ampere. Okay, in the previous problem it is 1. Because why it is plus 1? Because there we have taken clockwise rotation. We have taken clockwise. But here what about the current flow? The current is flowing, it is V minus 10. So the current flows from V to 10. So the direction is like this. It is like this. Okay, that's why it is represented as minus. If you are taking the clockwise direction, it will be plus. Okay. So the same answer you are getting in both mesh analysis and nodal analysis. Okay, thank you.